Give an example of an equation in standard form and then do all of the following. So an equation in standard form. So remember, standard form, it looks like this. And an example would be 2x plus 3y is equal to 12. To identify the intercepts, you have to set one of the variables equal to 0. So for example, for the y-intercept, you're going to allow x to equal to 0. So if I substitute it into the formula, into the equation that I provided, then you're left with 3y is equal to 12. And if I divide both sides by 3, y is equal to 4. So the y-intercept would be 0, 4. For the x-intercept, y is going to be 0. So if I plug in 0 for y, you get 2x is equal to 12. And if you divide both sides by 2, x is equal to 6. So the x-intercept is 6, 0. Okay. Right in slope-intercept form. So slope-intercept form is y equals mx plus b. So what I'm going to do is I'm actually going to solve for y. So I'll do it over here. So you want to get the y by itself. So the first thing you should do is subtract 2x from both sides. So 3y is equal to negative 2x plus 12. And then divide everything by 3 to get the y by itself. So y is negative 2 over 3x plus 4. That's the slope-intercept form. Once you have it in this form, it's very easy to find the slope. The slope is the number next to the x. So m is equal to negative 2 over 3. For number 2, describe the relationship between parallel lines. So that means that the slope is the same. Describe the relation between perpendicular lines. This means that the slope is opposite reciprocal. For example, let's say one of the lines is the slope is 2 over 3. Then the opposite reciprocal would be opposite, you change it from negative to positive, and reciprocal, you flip it. So it'll be 3 over 2. So it goes from negative 2 over 3 to positive 3 over 2. And then 4, describe how to shade the graph of an inequality. So if it's y less than or y less than or equal to, you're going to shade below. If it's y greater than or y greater than or equal to, you're going to shade above. And we're going to see an example right now. or below this one. So for number 1, given the equation 3x minus 2, let's graph it first. So first we're going to graph the y-intercept, which is -2. It's right here. And then our slope is 3, so I'm going to go up 3 units and run 1. You could do it a couple times. If you do it more times, it helps you draw your line a little bit more straight. And take your straight edge, connect it. Okay, and then it says write the equation of any line that is parallel. So if it's parallel, like I mentioned before, the slope has to be the same. So here, so this is g of x, so right here. So if the slope is the same, starts off at 3x. And your y-intercept could be any other number. So instead of -2, it could be 4. So 3x plus 4. And if I graph it, graph this in red, y-intercept is 4, up 3 over 1, up 3 over 1. You could see that if I connect these dots, you get a parallel line. Letter C, find the equation h of x that is perpendicular to f of x and passes through the point -6, -3. So perpendicular. So if I started off with the slope 3 over 1, remember you have to do opposite reciprocal, so it goes from positive to negative, and instead of 3 over 1, it's 1 over 3. Okay. And if it passes through the point -6, -1, all we have to do now is find the y-intercept. So the equation of the line is y equals mx plus b. The y value is -3. The slope is -1/3. The x value is -6. And then plus b. So we're going to simplify. -1/3 times -6. That's +2. And if I subtract 2 from both sides, you get -5. So now the equation is, here's my slope, -1/3. And here's my y-intercept, -5. And if I graph it, you should be able to see that it's perpendicular. So -5 is this y-intercept, and then down 1 over 3. Okay, and you can see how the lines are perpendicular. Okay, number 3. Given the equation below, identify the slope. So to do that, I'm going to change it from standard form to slope-intercept form by solving for y. So first, we're going to subtract 2x from both sides. And then you're going to divide everything by 3. So, oops. So So y is greater than negative 2 over 3x plus 3. So now we could see that the slope is negative 2 over 3. And then the y-intercept over here is the number that's by itself. That's positive 3. And the roots, we'll see it right now on the graph. So let's go ahead and graph it. So the y-intercept is 3. And the slope is down 2 over 3. Down 2 over 3. Now, this is an inequality. So you need to draw either a solid line or a dashed line. And you have to shade either above or below, like mentioned before. So another reminder, if it's less than or greater than, you're going to draw a dashed line. If it's less than or equal to, greater than or equal to, you're going to draw a solid line. This particular inequality is greater than, so we're going to draw a dashed line. And since it's greater than, we're going to shade above. So shade above the dashed line. So all that shaded region is a possible solution. Okay. And then the roots. Roots is where it crosses the x-axis. So it looks like it's somewhere around there. Or it's when y is equal to 0. Okay? So for roots, I'm going to do it in purple so you could see. I'm going to take the original equation and I'm going to set y equal to 0. So you're left with 2x is equal to 9. And if you divide that by 2, you get 4.5. So the root is 4.5, 0. This one only has one root. It only intercepts the x-axis at that one point. Concept 4. Solving quadratic equations. List and describe the 4 methods for solving a quadratic equation. Then give an example of an equation that you would solve by the specific method. What would a problem look like that you would solve by factoring versus quadratic formula? Okay. So this is 4, but you actually only need to know 3 for the final. One of them is inverse operations. For example, if you have x squared minus 1 is equal to 8, the opposite of minus 1 is plus 1. So you're going to add 1 to both sides. And the opposite of squaring something is square root. So you're going to find the square root of both sides. So that now x is by itself, and the square root of 9 is either positive or negative 3. Okay, that's how you solve with inverse operations. Another way is by factoring. So let's say you have something that looks like this. X squared plus 9x, plus 14 is equal to 0. To factor this, you're looking for numbers that multiply to 14 and add up to 9. And that's going to be 7 and 2. So those are your factors, x plus 7 and x plus 2. And then the values that make this 0 are going to be -7 and -2. Those are your solutions. And then the last method is going to be by quadratic formula. I'm just going to write the formula here, and we'll do an example below. So negative b plus or minus b squared minus 4ac all over 2a. Next, describe how you can tell how many roots a quadratic equation has without looking at the graph. So just how many roots, that's going to be the discriminant. And the equation for discriminant is b squared minus 4ac. If it's positive, it's 2 solutions. If it's 0, it's 1 solution. And if it's negative, it's going to be no solution. Okay. And then explain the process of rationalizing the denominator. So basically this means get rid of the radical sign. In the denominator. For example, let's say you have something that looks like this. You have 2 over the square root of 3. You need to rationalize the denominator because you're not allowed to have a radical sign down there. To do that, you're going to multiply the top and bottom by that denominator. You multiply the top and bottom by the square root of 3. That gives you with 2 square root of 3 over square root of 9. And we know that the square root of 9 is 3. So there you go. You got rid of the radical sign in the denominator. That's basically what it means. Here's some practice problems. Solve the equation seen here using any method. Leave your answers in the most simple radical form. So this one you could solve by inverse operations. So we're going to subtract 5 to both sides. Then you're going to divide both sides by 4. And then to get rid of the square, you're going to find the square root of both sides. And then you're going to subtract 1 on both sides. It does say the most simple radical. So the square root of 8, you need to simplify it. That simplifies to the square root of 4 times the square root of 2, which simplifies to 2 square root 2. So I'm going to replace that into the formula here. It's going to be plus or minus 2 square root 2. So plus or minus 2 square root 2 minus 1. So plus and minus means you're going to have a positive and a negative answer. Okay. Number 2, solve the following using any method that you would like. This one I'm going to solve using the quadratic formula. But first you need to set it equal to 0. I'm going to add 5 to both sides. So now I can use the quadratic formula. But first we need to identify the a, b, and c values. A is 2, b is -7, and c is 5. So using the formula above, x equals negative b, which is -7, plus or minus -7 squared minus 4 times a, which is 2, times c, which is 5, all over 2 times a. Okay, make sure you use parentheses to avoid making mistakes. Now we're going to simplify, so this double negative at the beginning turns into +7. 49 minus 4 times 2 times 5, that's 40. Over 4. So 7 plus or minus the square root of 9 over 4, which is 7 plus or minus 3 over 4. So here we need to find both answers. So you're going to have +3 or -3. So 7 plus 3 over 4 is 10 over 4, which is 5 over 2. Or 7 minus 3 over 4, which is 4 over 4, which is 1. Okay, so those are your two solutions. That was concept 4. Let's continue moving on. Concept 5. Graphing quadratics. Explain how you would find the vertex of each of the following forms of a quadratic. So in vertex form, the equation looks like this. And the vertex would be h comma k. So whatever those numbers are, just remember that's the opposite of the number in the parentheses. The number outside the parenthesis is the same. In standard form, to find the vertex, it's -b over 2a. So whatever those numbers are, you plug them in, you get the x value, and then you plug it into the equation to get the y value. Okay, and I'll show you some examples below. And if it's in factored form, for example, if it's in factored form, you just find the middle of h and k. So you would add h plus k and divide it by 2. And that'll give you the vertex. Explain how you would find the y-intercept of any form of the quadratic. So you just set x equal to 0 and solve for y. That will give you the y-intercept. For the roots, it's the opposite. You set y equal to 0 and solve for x. And here's some practice problems down here. All right, so you're given the equation. We're going to graph it and identify all of the following. Okay, so I see here that it is in vertex form. So h comma k is the opposite of the 1, which is -1, and then that number, 4. -1, 4. That's the vertex. Okay, we'll come back to the domain and range in a bit. The y-intercept is when x is equal to 0. So let's plug in 0 in the equation. Oops. So we plug in 0, we have negative 1 squared is 1. So -1 plus 4 is 3. So the y-intercept is 0, 3, which is here. Okay. To find the roots, you're going to let the y value equal to 0. Okay. So to find the roots, so I'm going to do that in purple. Put over here. You're going to have 0 equals negative x plus 1 squared plus 4. Okay. You're going to subtract 4 on both sides. So if I subtract 4 now, 0 becomes -4 equals to negative x plus 1 squared. I'm going to divide both sides by -1 to make the 4 positive, and the x plus 1 squared, you can make that positive. Okay. And then the square root of 2, you're going to find the square root of both sides. So plus or minus 2 is equal to x plus 1. And then you're going to subtract 1 on both sides. So -1 plus or minus 2 is equal to x. Those are your x-intercepts. I'm going to continue that up here. So if I add -1 plus 2, you get 1. If I subtract, you get -3. So those are your roots. At 1 and then -3. Sorry, I got that backwards. -3. Okay. And now we could draw it. Remember, we could use symmetry, so I could copy this point over here and then just connect them. There's your parabola. Domain is from left to right. So it's from negative infinity to positive infinity. And then the range is up and down. The lowest it goes is negative infinity. And then the highest it goes is here, which is 4. Bracket with 4. Number 2, Corey argues that the graph x squared minus 6x plus 8 is equivalent to the graph of y equals x minus 3 squared plus 1. Confirm or refute Corey's argument using any method. Be sure to show a graph of your equations. So I'm going to show you a graph of that. Just give me a second. So here's both graphs. So here's one, here's the other one. They're similar, but they're not quite the same. And I'm going to show you how to show that. So what you can do is the second equation here, you could change it back to standard form by actually multiplying out. So x minus 3 squared is actually x minus 3 times x minus 3. To multiply that, you're going to use FOIL. First, x squared, outer, minus 3x, inner, minus 3x, last, plus 9. And then combine like terms. So minus 6x plus 10. So see how the equations are almost the same. It's just this last number changes it. Okay, so that's one way to show. Okay, this is the last concept we're going to go over today. Concept 6, exponential functions. Describe the difference between exponential growth and decay. So for growth, it always increases, and the graph looks like this. For decay, this one always decreases, and the graph looks like this. Explain in words how to graph in the form a times b to the x plus k. Okay, so first you're going to graph the asymptote at k, then the initial value at a plus k, and then the multiplier to find the next point. So a plus k times b. And I'll show you what that means when we graph them. Describe how exponential functions differ from their graphs from linears and quadratics. So I drew some above. So they're either always increasing or decreasing. Okay, and they're in the form of a curve. Linears are, of course, they make straight lines, so that's how they're different. And then quadratics go up and go down. Okay, so those are the differences. Semiparabolas. Okay, so some practice problems here. Rules of exponents. So first, remember when you multiply numbers with the same base, you go ahead and add the exponents. So let me zoom in here. So I could actually add the 2 and the 4 because they both have the same base of x. So this is actually 2x to the 6, y to the 4th, over y to the third x. And then when you have a fraction, when you're dividing, you could go ahead and subtract the exponents. This x technically has an exponent of 1. So the 6 minus 1, that leaves you with x to the 5th. And then 4 minus 3 is 1, so y to the first power. We usually never write the 1. You can if you want, but usually don't write it. So that's your answer there. Okay, here, remember that anything to the 0 power is equal to 1. That actually goes away. And then when you have a power of a power, you go ahead and distribute that. So this is 2 to the third power, x to the third power, y to the second power over x. Another thing to remember, when you have a negative exponent, you move it. If it's in the bottom, you move it up. Or if it's already on the top, you move it to the bottom. So I'm actually going to write that y to the third power. I'm going to write it up here now because I want to make it positive. And once you move it, it turns positive. Okay, I'm going to simplify now. 2 to the third power, that's 2 times 2 times 2, which is 8. X to the third. And now here we can multiply these. Y to the second times y to the third. You add the exponents, y to the fifth over x. And here you could subtract the exponents on the x's. So you're left with 8x squared y to the fifth. B. Okay, now C. Okay, so even the fractions is the same rules. We're gonna distribute that there. So it's gonna be 4 to the power of 1/2 x. 2 times 1/2, that's actually just 1. So that's simplified nicely. Y to the 1/2, z to the 4th, over z to the 7th. If you punch in 4 to the 1/2 power into the calculator, you actually get 2. So I'm going to simplify that down to 2. X, copy it over. Y to the 1/2, you copy that over. And then the z, 4 minus 7 is actually -3. Okay? And remember, if you have a negative exponent, you bring it down to the bottom. So now your final answer is 2x y to the 1/2 over z to the third power. Oops, sorry. That's A, B, and C. And then down here, graphing. All right, so we're going to graph this problem here. 3 to the power of x plus 1. I'm going to write a 1 here in the front because technically there's a 1 there. It's going to help us. First thing we're going to draw in is the asymptote. The asymptote is 1. So at 1, we're going to draw a dashed line. This is the asymptote. the asymptote. Okay, and then our initial value, like I said above, it's a plus k. A plus k in this case would be 2. And then to find the next number, you multiply x plus k, which is 2, you multiply it by b. B is 3, so 2 times 3 would be 6. So the next number is 2, 4, 6. Okay, and this one is always increasing. So there's your graph. Okay, the asymptote is there, so you won't cross it. Okay, you cannot cross the asymptote. All right. So let's start filling these things here. So the domain is from negative infinity to positive infinity. The range, the lowest it goes is actually at that asymptote. So it's from 1, and it goes all the way up to infinity. So from 1 to infinity. The y-intercept, we see it here on the graph, it's 2. So 0, 2. And then interval of increase and decrease, don't worry about that. And you can see here that it's growth, all right? It's always going up.